Hello, this is your lucky sir. NCRT, we are discussing haloarenes and haloalkanes. Lecture 2, Nature of CX bond. Halogen atoms are more electronegative than carbon. Therefore, carbon halogen bond of alkyl halide is polarized. The carbon atom bears a partial positive charge, whereas the halogen atom bears a partial negative charge. As we go down the group, the periodic table, the size of the halogen atom increases. Fluorine atom is the smallest and the iodine atom is the largest. Consequently, the carbon halogen bond length also increases from CF to CI. Some typical bond lengths and bond enthalpies and dipole moments are given in table 6.2. Alkyl halides are best prepared from alcohols which are easily accessible. We'll go to the preparations. But before that, you see CH3F, Cl, Bri, iodine being larger, so bond length is increasing, so nothing special here. And bond enthalpies, when bond length increases, bond enthalpies decreases. No need to remember any values, don't remember. Dipole moment 1.847, 1.860, 1.830, 1.636. This is bit interesting because dipole moment is actually mu is equal to dou into L, means charge and length. In case of chlorine, the dipole moment we expect for fluorine more, but chlorine is more. Okay, na? So CH3Cl dipole moment is more than CH3 of this point you need to remember. Okay, na? This point is important for your entrance examinations. Coming to the methods of preparation of haloalkane, the hydroxyl group of an alcohol is replaced by halogen on reaction with concentrated halogen acids, phosphorus halides, thionyl chloride. Thionyl chloride is preferred because in this reaction, alkyl halide formed along with the gases SO2 and HCl. The two gaseous products are escapable, hence the reaction gives pure alkyl halides. The reactions of primary and secondary alcohols with HCl require the presence of a catalyst ZnCl2. With tertiary alcohols, the reaction is conducted by simply shaking with alcohol with concentrated HCl at room temperature. Means tertiary alcohols are more reactive. Constant boiling with HBr 48% is used for the preparing alkyl bromides. Good yields of Ri may be obtained by heating alcohols with sodium or potassium iodide in 95% orthophosphoric acid. Okay, now good yields of Ri may be obtained by heating alcohols with sodium or potassium iodide in 95% orthophosphoric acid. Important line. The order of reactivity of alcohols with a given halo acid is tertiary, secondary, primary. Just now we were discussing. Phosphorus tribromide and triiodide are usually generated in situ. In situ means in the reaction. By the reaction of red phosphorus with bromine and iodine respectively. There is no need to use PBr3 or PI3. Just use P plus I2 like that. Very important reactions you see. HCl, anhydrous ZnCl2. This is called actually Lucas reagent. It's a test for primary, secondary, tertiary alcohols which we are going to discuss in next lesson. NABR H2SO4 when you are using, you will be getting their RBR. PX3, you are using their RX. And PCl5, you are getting their RCl plus HPO. The side products you see H3PO3 and this is POCl3 like this. And red phosphorus X2, X plus is bromine and iodine. You can use directly RX. SOCl2, this is preferred because the two are gases. Fine, very important reactions. So 6 reactions are there. One is given with HCl, ZnCl2 Lucas reagent. Second is given NABR H2SO4. Then PX3. PX3 means you can see PCl3 and PBr3. PCl5, you will be getting their POCl3. This is H3PO3. This is important side product. And when alcohol is treated with red phosphorus in X2, that is bromine and iodine, you will be getting their RX. And SOCl2 is preferred because the two are gases. The preparation of alkyl chloride is carried out either by passing dry hydrogen chloride gas through a solution of alcohol or by heating a mixture of alcohol and concentrated aqueous halogen acid. Okay. The above methods are not applicable for the preparation of aryl halides because the carbon-oxygen bond in phenol has a partial double bond character and is difficult to break being stronger than a single bond. For example, it is like this OH. From alcohols you can, but here you cannot because of this resonance type of things. Then from hydrocarbons, from alkanes by free radical halogenation, free radical chlorination or bromination of alkanes gives a complex mixture of isomeric mono and polyhaloalkanes, which is difficult to separate as pure compounds. Consequently, the yield of any single compound is low. So not preferred if you want to go for butane chlorination. It can come at first place or it can come at second place. Okay, all chances will be there. So not preferred, and this we were discussing completely in class 11. Okay, from alkenes. Addition of hydrogen halides. An alkene is converted to corresponding alkyl halide by reaction with hydrogen chloride, hydrogen bromide, and hydrogen iodide. Obviously, the Hi addition will be faster than HBr than HCl because Hi bond energy is less. Very simple. Propene yields two products, however, only one predominates as per Markovnikov's rule. Okay, now Markovnikov's rule is H will be added here, iodine will be added here, rich becomes richer. So this is major. And you know about the anti-Markovnikov addition, HBr peroxide, all that we were doing in class 11, you can check that. Addition of halogens in the laboratory, addition of bromine in CCl4 to an alkene resulting in discharge of reddish brown color of bromine constitutes an important method for the detection of double bond in a molecule. It's a test for unsaturation, we can say. The addition results in the synthesis of vicinal dibromides, which are colorless. See bromine, this is reddish brown in color, it is colorless. Identify all the possible monochlorostructural isomers expected to be formed on free radical monochlorination of CH3 to CH, CH to CH3. You see, this compound is actually 4 carbons like this. And chlorination is asking monochloro. So chlorine can come at this place, chlorine can at this place, chlorine can come at this place, chlorine can come at this place. Okay, now these are the 4. And when don't write as it is stuff like this. Write like this, it will be easy. You are keeping at first place, you are keeping at second place, you are keeping at third place, you are keeping at fourth place. That's it. Alkyl halide iodides. Okay, alkyl iodides are often prepared by the reaction of alkyl chlorides or bromides with sodium iodide in dry ether. This reaction is called Finkelstein reaction. Rx plus Na gives us to Ra plus NaX. This is said to be SN2 reaction. Remember this point. NaCl or NAB are thus formed is precipitated in dry acetone. It facilitates the forward direction according to Lee-Shortley's principle. The synthesis of alkyl fluorides is best accomplished by heating an alkyl chloride or bromide in the presence of metallic fluorides such as AgF, Hg2F2, COF2 or SbF3. This reaction is called Schwarz reaction. AgF, you can use Hg2F2, COF2, SbF3. Preparation of haloarenes from hydrocarbons by electrophilic substitution. Any aryl chlorides and bromides can be easily prepared by electrophilic substitution of arenes with chlorine and bromine respectively in the presence of Lewis acid catalyst like iron or iron 3 chloride. First year benzene EAS, electrophilic aromatic substitution we were discussing. Okay, now here it is taken toluene. Toluene, this CH3 group is ortho-para-dialectic group, so it will be coming at ortho place or at para place. The ortho and para isomers can be easily separated due to large difference in their melting points. Reactions with iodine are reversible in nature and require the presence of an oxidizing agent like HNO3 or HiO4 to oxidize the Hi formed during iodination. Fluorocompounds are not prepared by this method due to high reactivity of fluorine. From amines by Sandmeyer's reaction. When a primary aromatic amine dissolved in suspended cold aqueous mineral acid treated with sodium nitrate, a diazonium salt is formed. Mixing the solution of freshly prepared diazonium salt with cuprous chloride or cuprous bromide results in the replacement of diazonium group by Cl or Pr. This reaction is known as Sandmeyer's reaction. Very similar reaction, you can use even Gattermann also. I think that is not mentioned here. See NH2, NaNO2, HCl at ice cold condition 0 to 5 degrees Celsius, you will be getting their benzene diazonium halide. And when this benzene diazonium halide is treated with Cu2X2, where X is chlorine or bromine, you will be getting their chlorobenzene or bromobenzene, not for fluorobenzene or iodobenzene. Replacement of the diazonium group by iodine does not require the presence of cuprous halide and is done by simply shaking the diazonium salt with potassium iodide. Okay, no need of Cu2X2, let's go for K. Write the products of the following reactions. You see, this is HBr. When you are using HBr, you see plus charge is stable here because this is attached to benzene. Stability will be there. So bromine will be coming here. Bromine will come here. Hydrogen will come here. See here, this place will be H, this place will be chlorine, normal, Marconic of addition. This is again, okay, now, because this is nothing special, so hydrogen will be added here, bromine will be added here. Oh, peroxide is here, na? Peroxide when it is there, anti-Marconic of addition, so bromine will be coming here. Why is sulfuric acid not used during the reaction of alcohols with Ki? Why you use only, what you say, HCl? Why is sulfuric acid not used during the reaction of alcohols with Ki? This is first question. We will discuss all these questions. Write structures of different dihalogen derivatives of propane. Among the isomeric alkanes of molecular formula C5H12, identify the one with photochemical. These are the three questions and some questions are here. Before going to physical properties, we will discuss all these questions. Okay, na? That will be in lecture 3. Okay, this is lecture 2. We'll do that in lecture 3. Lecture 3, only these questions. Then lecture 4, we'll go with physical properties. Thank you.